Then for methyl secondary alcohols, or methyl secondary alcohols, methyl secondary alcohols have this structure. The reaction still occurs in the same way. They have that structure. You have a CH3 close to CH, yeah? That's why I'm calling them methyl secondary alcohols. Otherwise, if you are looking at CH3, CH2, CH, CH2, CH3, OH here, this is not a methyl secondary alcohol. It doesn't undergo iodoform test. I've emphasized that. Now, the equation does not differ much. So we have RCH, CH3, OH with the iodine in presence of sodium hydroxide on warming. Iodine does the same thing. Iodine picks this CH3. So what do we get? We get CHI3. Then plus the remaining part is oxidized to a salt of a carboxylic acid. As a salt of a carboxylic acid plus some other minor products. Yeah. You have minor products, you have sodium iodide and water. Yeah. If I take a specific example, look at the propan-2-ol. I want to say that propan-2-ol is a methyl secondary alcohol. Propan-2-ol with the iodine, sodium hydroxide, warm. I think I still have some minutes. Let me check and see. Oh, there are 9 minutes. Okay. Warm. So what do I get? Iodine, fix the methyl thing. Then the other parts, we are left with the 2 carbon atoms. So the salt is the sodium ethanoate. Yeah. There are some minor products, sodium iodide and water. There are those minor products. Sodium iodide and water. Then also in some books you find this representation. Also in some books you find that they write what? They write this is the general equation. If you don't want to represent it in that form, in some books you are going to find this plus iodine plus sodium hydroxide. You form iodine takes the other part, the yellow precipitate, then you get what? The left part is oxidized. What is the left part in this case? So iodine takes this, then we are left with RC. We are left with RCOONA. It is oxidized to that. Then plus sodium iodide. This is in solution. This is in solution. Solution, liquid. I want to balance this. I can put a 4 here. If I put a 4, there are 8 iodines. These are already 3. I can put a 5 here. So the atoms of iodine are balancing. Then I look at what? I hate balancing equations. I look at the sodium. This side we are having 6 sodiums. 1 here and the 5 there. So there are 6. I can put a 6 here. If I put a 6 this side, then I'm having, these are 6 oxygens. There are 6 oxygens, but there is also another one there. So there are 7 oxygens on the left. However, this side I already have 2. So I'm having a deficit of 5. So I'll add 5 moles of water this side. So 5 moles of water would imply that I have 10 hydrogens plus another one here. Those are 11 hydrogens on the right. Then on the left, this 6 multiplies here. Those are what? 6 hydrogens. Plus this one here, 7, 8, 9, 10, 11. The equation is balancing. So what am I left with? I am left with, how many minutes do I have? There are 6. Also, earlier on I mentioned that ethanol and ethanol, for ethanol and ethanol undergo this kind of reaction. For ethanol, you have CH3, CHO with the sodium with the iodine in presence of sodium hydroxide on warming. Iodine picks the CH3, so we get CHI3. So what are we left with? What are we left with? We are left with CH. So CH is oxidized to HCOONA, sodium methanoate. There are other minor products of sodium iodide and the water is there. Then for ethanol, we can have CH3, CH2OH reacting with the iodine, sodium hydroxide, warming. So iodine picks the C, the other methyl component, so you get this. Then plus, we are left with the 1 carbon. 1 carbon is oxidized to sodium methanoate. Yeah, like that. So the yellow precipitate is that of, this is the yellow precipitate is that of triiodomethane. Allow me stop here and end this session.